Hello viewers, welcome back. Today's video lecture we are going to talk about the hydrohalogenation of alkene. In the previous lectures we discussed the various reactions of alkane. In the first lecture we learned the hydrogenation, adding hydrogenation, that is H2, halogenation, we learned this bromine, and followed by halohydrin, etc. Here we are doing the hydrohalogenation. Listen carefully. We are learning, if you learn a topic with certain sequence, it is very easy to remember. That's why I structured this sequence of reactions. Now we are going to see the hydrohalogenation, that is HX. Now if you observe, you see the HBr reacting with alkene. Here the hydrogen may be add any of the alkene carbon and we will get different isomers. But in the previous case both atoms are same, both are hydrogen, here both are bromine. So it may add any of the carbon, it doesn't matter. But only the pattern of addition, either it is a syn addition or anti-addition, that is the difference. But here both are at different atoms. Now which atom will add it to which alkene carbon? So that matters a lot. That's why this reaction is a most regioselective reaction, and that product depends on the carbocation stability. In conclusion, this reaction is called as Markovnikov addition. Now let's see how the reaction mechanism takes place for this product formation. Now take this alkene, I numbered, so this is the first alkene carbon and this is the second alkene carbon, and here it is there is a CH2. Now the proton may be added either in the first carbon or in the second carbon. If it is added in the first carbon, it will form like this. So this is the pathway A. If it is added in the second carbon, that is the pathway B. So that we will get this a primary carbocation. The outcome of this, after addition of the proton, we get the intermediates. One is tertiary carbocation and another is the primary carbocation. We know that the stability of the carbocation order is tertiary is always most stable than the secondary, followed by primary, followed by methyl. Now which one will always form in the major amount? It depends on the stability of the carbocation. That means this carbocation will be formed in the major amount. Then this bromide ion will come and attack this carbocation, so we will get this as a major product. But this is a least stable, so why this will form in the very minor, the least. So if it attacks this primary carbocation, so finally we will get like this. But this is a minor product. So we should always concerned about the major product formation, but it always depends on the carbocation stability. I hope you understand it. So first what you have to do is you have to add the proton, that is hydrogen, both of the alkene carbon, and check the carbocation stability. Then you attack this bromide ion to the most stable carbocation according to the order given. So that's all. Now let's see another example of alkene. So this is one alkene and reacting with HBr. Here this is forming as a major product. Why? Let's see. Now so this is the first alkene carbon and this is the second alkene carbon. So if it is added at the first, the hydrogenated or protonated, so it will give the secondary carbocation. So we may expect that So this is the most stable carbocation, so this will can attack the bromide ion and we should get this one. But this is not formed as a major, because the reason is here the carbocation itself get stabilized by the rearrangement. How? You see here this hydride, this hydrogen is coming along with this electron pair and it getting shifted here. As a result, this will become a tertiary carbocation. So always you should check, is there any possibility of carbocation rearrangement before this allied ion attacks the carbocation. So this is the must. Most of the students, they will forget it. Okay, first in the initially they will add the hydrogen, both any of the alkene carbon, and see the stability. From that they will decide it, but they may forget it. Is there any possibility of rearrangement? Even in the case of, instead of hydrogen, you may have the CH3 also. So that will also migrate. So in that case also it will get the tertiary carbocation. Anything, either hydrogen or methyl, anything it can migrate. Okay, that you should remember. So once there is a rearrangement occurred of carbocation, it will get the most stable carbocation. We know this tertiary carbocation is most stable than the secondary. Now this bromide ion attacks, then we get this rearrangement product. So this is the main important information we should always remember in the hydrohalogenation reaction. Okay. Now we are going to see one more condition. If the hydrohalogenation occurs in the presence of peroxide, then what will happen? Here it will give different product than the absence of peroxide. Again, it is a regioselective reaction, but the outcome of the product depends on the free radical stability. So any alkene react with this HBr in the presence of peroxide, so that reaction is called as anti-Markovnikov addition. You see the previous example, this only we have seen. Here there is no peroxide, we get this product. But in this case we had added the peroxide. You see the bromine and hydrogen are added in the different way, in the opposite way. Okay, if you observe it, you can understand it. Okay, now we see how this mechanism takes place. Here this peroxides undergo by homolytic cleavage and it forms a radical. So please learn the homolytic and heterolytic cleavage that I given in the description link. Please understand it. Okay, so once this radical is formed, so it is more active intermediate and it will react with this halogen acids. So it form like this and this bromine radical. Now this bromine radical will become more reactive and it may attack any of the alkene carbon. Now if it is attacked at this first alkene carbon, you see, and it forms this tertiary radical. Suppose if I attack at this second alkene carbon, in this carbon, suppose like this, so what we will get? We will get this one. So we will get bromine here and here we will get CH2 like this. Now this is a primary radical and this is a tertiary radical. We know the stability order, this one free radical, as it is as similar as we learned in the carbocation. Carbocation stability order and free radical stability order is same. You see here also the tertiary radical is most stable than the secondary followed by primary. Now you see, compare it. So this is most stable. So as we know that the most stable intermediate only will give the major product. Okay, so this one, that is tertiary radical, attack again this hydrogen, this halogen acids, it abstracts the hydrogen and it forms, this is the product. Okay, so this is the reason behind the peroxide. Okay, so it induces the free radical and outcome of the product depends on the stability of this radical intermediate. Okay, so this was the conclusion. Before concluding the topic, let me add one more important information. If you add HCl or HBr, other than HBr like HI and HF, this will not give no anti-Markovnikov product. Okay, even if you add peroxides, so that you should remember. So it will give only Markovnikov addition. Okay, Markovnikov addition. And so this is the key point you should remember. For example, I write one reaction, so like this. If react with HCl, even in the presence of peroxide, we should get this product, but this is not formed. Okay, it will give only that carbocation stability related. Okay, so it is followed by ionic addition. In simple, you can say like this. This only it will form. So this will form only this product. This will not form. Okay, that's why I am telling. So please remember that even if you take any halogen acids other than HBr in the presence of peroxide, it will not undergo anti-Markovnikov addition. It will obey the Markovnikov addition by applying ionic addition. So this you should remember. That's all. I hope you understand this lecture. Kindly subscribe and share this video lecture if this video lecture find useful. Thank you very much.